Hi students, welcome to the chemistry session. Today we are going to discussing about chemical reactions and chemical equations. Okay, chemical reactions and chemical equations. So we know in our day-to-day life we can observe many types of chemical reactions. So here every chemical reaction we are representing with a chemical equation. Here chemical equation which is composed with symbols and formulas, as well as chemical equation tells about direction of the reaction, as well as chemical equation also tells about physical states of reactants and products, and also whatever the necessary conditions to takes place the reaction also mentioned in the chemical equation. Okay, this is about chemical equation. See here, I wrote one chemical reaction and chemical equation. So 2 moles of potassium nitrate formula KNO3. Decomposition by heating gives 2 moles of potassium nitrate, and here this is potassium nitrate, and what we get potassium nitrite. Okay, if a compound contains more number of oxygens, suffix we have to add 8, less number of oxygens, suffix we have to add ite. So here 2 moles of potassium nitrate on decomposition by heating gives 2 moles of potassium nitrate. So, and also one of the byproduct is 1 mole of oxygen. So this is the matter. So whatever the chemical reaction takes place, so in a chemical reaction we are explaining with words, whereas in chemical equation simply it is a shorthand notation of a chemical reaction, that is called chemical equation. Here there is a formula for potassium nitrate. So KNO3 on decomposition by heating it decomposes into potassium nitrite and oxygen. So this is about reaction and equation. So next here one more example is there. So that is a chemical equation. 2 moles of carbon monoxide react with 1 mole of oxygen. Here the product is 2 moles of carbon dioxide. So 2 moles of carbon monoxide react with 1 mole of oxygen, forms 2 moles of carbon dioxide. So here the given equation gives the following information. What is that following information? So here 2 molecules of carbon monoxide react with 1 molecule of oxygen, produces 2 molecules of carbon dioxide, as well as 2 moles of carbon monoxide react with 1 mole of oxygen, produces 2 moles of carbon dioxide. Also here molecular mass of carbon monoxide which is 28 grams, oxygen molecular mass is 32 grams, carbon dioxide molecular mass is 44 grams. So we can say 2 into 28 grams of carbon monoxide react with 32 grams of oxygen to produce 2 into 44 grams of carbon dioxide. Okay, so as well as we can say 2 volumes of carbon monoxide. Why? Because why I'm saying with volumes? So carbon dioxide is a gas, oxygen is a gas, carbon dioxide is a gas. So here 2 volumes of carbon dioxide react with 1 volume of oxygen to produce 2 volumes of carbon dioxide. So from this what we can understand, so a chemical equation gives the following information. What is about that? It tells about it gives the information about molecular information, okay, molar information, and weight information, and volume information. So chemical equation mainly tells about molecular information, molar information, weight information, volume information. Next we are going to discussing about stoichiometric calculations types. So here stoichiometric calculations are mainly 3 types. One is calculation based on weight relations. Okay, let us do one problem about stoichiometric calculations of types. Next, second one is calculation based on weight volume relations, and a calculation based on volume relations. Okay, weight relations, weight volume relations, volume relation. What is weight relation? If the all the reactants are in solid state, so at the time we are taking weight. Okay, if the reactants react, they produce a product. If it is also a solid, then we are see the weight relationship between reactant and product. Here also weight volume relation means reactants are solid, then we have to take their weight. If the products are gaseous substances, we have to take volume. Okay, volume relationship means how, like we taken in this example here, the both the reactants and products are gaseous substances. That's why in that condition we have to take volume relation. So this is about types of stoichiometric calculations. So next, and two more definitions, important definitions are there. So one is law of combining volumes, and another one is Avogadro's theory. So law of combining volumes proposed by Gay-Lussac. Okay, it is the scientist name, Gay-Lussac. So according to law of combining volumes, okay, when the gaseous substances react in a chemical reaction and they produce gaseous product. Okay, here whatever the number of moles of gaseous reactant participate in the reaction, whatever the number of moles of gaseous products produced in a chemical reaction, which is always a simple whole number ratio. For understanding purpose, I will write one example. See here. For example, we know Haber process. We can prepare ammonia. So in that, nitrogen react with hydrogen, so forms NH3. So to balancing the equation, we have to take 3 moles here. So here 2 NH3. So N2 plus 3H2 gives us 2 NH3. Here 1 mole of nitrogen combines with 3 moles of hydrogen, produce 2 moles of ammonia. So whatever these are all gaseous substances. Nitrogen is a gas, hydrogen is a gas, ammonium is a gas. Okay, here the reactants are the gaseous substance and the produced product is also a gaseous substance. So from that what we can understand, okay, in their in reactant side the number of moles which are in simple whole number ratio, and product side also their number of moles are simple whole number ratio. So that is about law of combining volumes. Okay, so the reacting gaseous species are produced gaseous substance which are simple whole number ratio. That is about law of combining volumes. Next definition, Avogadro's theory. So Avogadro's theory means equal volumes of all gases contains same number of molecules. Okay, equal volumes of all gases contains same number of molecules at a same temperature and pressure. Okay, we have to consider the pressure and temperature. Okay, equal volumes of all gases at same temperature and pressure contains same number of molecule. For understanding, we have to take one volume of if you take 1 volume of hydrogen gas. Okay, already we discussed about so different stoichiometric calculation based on weight relationship, weight volume relationship, and volume relationship. So here I take I wrote one problem based on weight volume relationship. Okay, weight volume relationship between the reactant and product. So the problem is, let us calculate the amount of potassium chlorate required for the liberation of 5.6 liters of oxygen at STP condition. Okay, let us calculate the amount of potassium chlorate required for the liberation of 5.6 liters of oxygen at STP. STP full form standard temperature and pressure. So to calculate the based on weight volume relationship, okay, so some steps involved in this problem, in this solution. So first step, write the balanced chemical equation. Whatever the terms given in the question, basing on that we have to write a chemical equation. So potassium chlorate liberate 5.6 liters of oxygen. So potassium chlorate KClO3 Okay, gives rise to, on decomposition, it's decomposes into KCl plus O2. Okay, KCl plus O2. So this is an unbalanced equation. That's why I will put here 2 moles, 2 moles. So KCl is on both sides of the reactant is balanced, but number of oxygen atoms are not balanced in right side. So that's why I will multiply with 3. Whatever it may be. Before unbalanced equation, now changed into a balanced chemical equation. So how I wrote this balanced chemical equation, whatever the information given in the question, basing on that terms, I wrote a chemical equation here. Okay, first step, what is it? Write the balanced chemical equation. So basing on the question, I wrote a balanced chemical equation. Next step 2, identify the terms involved in the problem. So what they asked, so 2 moles of potassium chloride react on decomposes, 2 moles of potassium chloride on decomposes gives 3 moles of oxygen. So already we discussed molar volume. Molar volume means 1 mole of any gas occupies at STP conditions 22.4 liters. So here 3 moles means 3 into 22.4 liters. See here. So finally we have to calculate, to produce 5.6 liters of oxygen, how much amount of potassium chloride required. The required amount in grams we have to calculate. Okay, in grams, what they give on decomposition of potassium chloride, how much amount of potassium chloride required to produce 5.6 liters of oxygen at STP condition. So that is the step 2. Whatever the compounds involved in the chemical equation, what are the gaseous products obtained, so how much amount of gaseous product is obtained, how much amount of required to produce such amount of gaseous substance. So basing on that, so finally to produce 5.6 liters of oxygen, how much amount of potassium chloride required we have to calculate. Step 3, get a standard relationship between the identified terms from the balanced chemical equation. Already we wrote in the first step balanced chemical equation. See here, potassium chlorate molecular formula and molecular mass is 122.5 grams. Why I put 2 means here 2 moles of potassium chloride is there. So potassium chloride formula 122.5 grams. And here majorly we are discussing about potassium chloride and oxygen. Okay, we should ignore about potassium chloride. So in question, how much amount of potassium chloride required to produce 5.6 liters of oxygen they asked. That's why we should concentrate on potassium chloride and oxygen. Okay, so 2 into 122.5 grams of potassium chloride react with 3 into 22.4 liters of oxygen. So what they asked, 5.6 liters of oxygen to produce how much amount of potassium chloride required. So here I taken x grams of potassium chloride. So okay, we have to multiply crossly. So 5.6 into 2 into 122.5 by next to 3 into 22.4 liters. So this 2 cuts 22 11.2 times. So whatever it may be, we after complete the calculation, finally we get 20.4 grams of potassium chloride. So to produce 5.6 liters of oxygen, so required amount of potassium chloride is 20.4 grams. So this is about based on weight volume relationship. Okay.